Welcome back. This is the second lesson of week 15, and in this lesson we're going to look at the structure of a typical recursive function. In this lesson we'll review how you recognise recursion and how recursive functions are written so that the recursion can stop, otherwise they'd go on forever. We'll identify and name the key features of a recursive function, and we'll quickly look at how to make a recursive function. We'll do more about that next lesson. So I said this before, but to recognise recursion, you look for the name of the function inside the function. Here's something else to notice. It's often the final line of the function following the word return. That would be the typical structure of a recursive function. Look for the name of the function following the word return. We've seen how a recursive function calls itself and then calls itself again. Each copy calls a new copy, but we've got to stop that somehow or it will go on forever. For this reason, every recursive function has a second feature called the base case. This is the word return without the name of the function. So when the function reaches the base case, the recursion stops and it returns a value without any more recursion. The base case is an if statement. Some people write functions in different ways, but the way I always write them is to put the base case at the top of the function definition. It includes an if statement with a logical test. If that test is true, the recursion will stop. You've reached the end of the recursion. So to recap what we've just learned, a recursive function has the word return followed by the name of the function. Before that, it has an if statement with some kind of test that stops the recursion. And if that test is true, it will return a value without any more recursion, and that's how the recursion stops. So every recursive function will have roughly the structure shown on this screen. Most recursive functions use parameters. Remember that each recursive copy opens a new area of memory, a completely new area of memory. In fact, before you reach the base case, there's usually a whole chain of new recursive functions opened in memory. There's got to be some way of passing values along the chain, and we use parameters to do that. So most recursive functions have one or more parameters. So I can slightly expand the structure of the recursive function that we've already looked at. You can see I've added a parameter. The parameter will come at the top of the function where we start to define the function, and it will come at the very end where we call the name of the function a second time. And there will be some other commands which will typically go in between the base case and the final recursive line. Whatever those commands are, that will really depend on what our function does. So to go back over what we've just said, a recursive function has got the name of the function, usually with some parameters. The function is then called again, usually at the end of the function following the word return, and notice we're using the same parameters. That's the recursive part of the function. We will also have some kind of if statement that allows us to stop the function. This is called the base case. We've got the word return followed by a value rather than another recursion. And finally, we would have other commands somewhere inside our recursive function. So just to recap, in every recursive function, the function will call its own name. It typically has the word return followed by its own name. It'll have a base case which stops the recursion. The way that I write it, the base case comes at the top and it's an if statement. Most recursive functions include parameters because that's the only way you can pass values up the chain. And then typically, of course, there will be other commands, whatever it is that your function has the job to do. So I'm setting you a programming task. See if you can write a recursive function that creates a list of letters entered by the user. And as the base case, if the input letter is X, the recursion will stop and the function will return the list. Use the pointers that I've given in this lesson to try to make that function for yourself. If you've got the function working, call it from the main program and include a command that will print out the completed and returned list. Then prepare a document to show your code. Take a screenshot of any code that you have managed to write. Drop it into a Word document and add notes to identify the different parts of a recursive function. The base case, the parameters, the recursive part, and any other commands that you have decided to include. I will go back over this in the next lesson, so do your best and see you soon. Bye for now.